Welcome you all students for this lecturing video regarding GSM and TDMA technology. So, under this you are going to learn about GSM infrastructure and communications. So, it is a layer 3 diagrams. It usually start with the layer 1, layer 2 and layer 3. So, as you learnt about YSI models in communication computer communication networks, similar manner. So, layer 1 as you know the physical layer which is going to be connected to networks. Data link layer is held responsible to transmit the data packets. So, layer 3 is going to be is responsible to connect the networks similarly. So, here also the layer 1, layer 2 and layer 3 which is going to be a flow between the two nodes in the network. So, let us take the review of GSM protocol architecture. So, that is as shown in the figure. As shown in the big figure here. So, the information flow between the two nodes in a network. So, that is going to have that is a flow of information between the two nodes in a network. That is we learnt using the application is sent down through the protocol stack across the physical interface and up through the protocol stack of the receiving node. So, within the same layers in different nodes, they are peer entities that communicate with each other through the use of the specific protocol. So, between the adjacent protocols, so called service primitives are used for communication between the different entities. So, these service primitives are very much important that provide the means by which the information is carried over a boundary common to adjacent layers. So, this information transfer occurs at the service access point. So, in short form it is known as the service access point. You are able to see on the diagram. So, here it is going to be a service access points. So, which is a legal concept defined by the OSI model. So, the SAP is defined by its service access point identifier. So, that is known as the SAPI value. Okay. So, let us learn layer by layer. So, come to the layer 3. So, it is going to provide the mobile network signaling service for the mobile subscriber application. So, the MNC, that is the mobile network station, which is the MNS operations include the following. One is that is the mobile network signaling, that include the following management. One is connection management function to establish or maintain and terminate the circuit switch connections from PSTN to GSM, and subscriber functions to support short message services to the subscriber. So, the next is the function to support the supplementary services and function to support the radio resource, and the mobility management is the last layer. So, let us deal with the one by one. So, the layer 3 is going to have the sub layers which is been that is the sub layers are connection management, mobility management and the radio resource management. So, as shown in this figure, you are able to see it is on the screen. So, here that mobile station contains all 3 sub layers and these respective protocol entities on the network side of the air interface. So, the connection management and mobility protocol entities only reside within the mobile service center. So, the resource entity, resource management is entity reside primarily in the base station controller. However, that is the resource management, radio resource management functions may reside its BTS and the MSC. Okay. So, let us learn one by one what is the control management. So, under control management there is a subcategories, that is one is the call control, other one is the short message service support. So, what happens in the call control? The call control, that is identified as CC, procedure are used during the call establishment for mobile oriented call. So, the mobile subscriber starts to call the establishment procedure by dialing the digits and by pressing send but on the mobile station keypad. What is this process is known as? This process is known as man machine interface, that is in short form it is known as MMI procedure, and these procedures are mapped onto call control procedures through an exchange of service primitives over the mobile network. CC service access points. Okay, so in the figure 5.48, you are able to see when when the request is made, you are able to see when a request is made to establish a call, a free or idle CC is nothing but call control entity is used to establish the call control connection between the mobile station and the GSM network. The call control entity initiates the call establishment by requesting the mobility management sublayer to establish mobility connection. When the mobility management sublayer confirm the establishment of connection to the particular call control entity, sends the setup message to the prior entity, that is the mobile switching center. On the other hand, that is the when CC, that is call control messages are then exchanged after connecting the acknowledgement messages have been exchanged. Because acknowledgement should exchange, because the many of the mobile stations are included, many of the BCDs are included. So, the authenticated user only receive the call, or the destined receiver only should receive the call. So, the two peer sublayers enter in an active state and call establishment signaling phase is complete. When the mobile terminating call occurs, so the call control entity establish the connection between the network and the mobile station is located in the mobile switching center. So, call control is only establishing the connection and it is only terminating the connection. So, call clearing procedures are initiated through the sending of a disconnect message to the call control entity. After the exchange of release the complete messages, so the connection is released and the CC entity is returned to an idle or the null state. This is how the call is established and even the call is got terminated. So, how it is going to handle the short message services? Short message services entities known as short message controller use a short message control protocol. These entities are used to transfer a short message between the mobile station and mobile switching center. So, the SMC entities provide service to the SMS, that is what the short service message controller. Earlier it was the call controller, now it is got shifted to short message controller, service controller. Entities provide the service to the SMS application through the mobile network, that is known as the SMS service access point. That is known as the SMS service access point. So, next these two are the call and the message service, okay, short message services. Next one is the supplementary service support. What it does? Supplementary service handle services that are not related to a specific call, for example, call forwarding and call waiting. So, this information is handled by, that is these informations are known by the home location register through the messages related to the appropriate service. So, the SS entities provide, that is the supplementary service entities provide the service through the mobile network. So, the SS services access points, that is known as the MNSSSAP. Okay. So, that is known as the mobile network supplementary service access points. Okay. So, next one is the mobility management. So, here you are able to see the parallel call control operations. So, under this the mobility management sublayer performs 3 types of procedures that are related to the mobility support subscriber confidentially. So, the service of CM entity and the mobility support procedure are also known as the that is the mobility management specific procedures, and they include the different location updating types. So, the mobility management procedure used to provide the subscriber confidentially and include the authentication, that is temporary mobile subscriber identification reallocation and that is the mobile station identification, that is IMSI or IMEI. You know, S is for subscriber identity, EI for equipment identity. So, the mobility management, connection management procedure also provides service to the different entities in the CM sublayer. So, these services allow the CM entity the ability to use the connection for communication with its prior entity to the MS or MSC, or it is going to intimate the mobility connection either mobile station or the mobile switching controller. So, when the sublayer receives a request for connection from a CM entity, so the sublayer sends the request message for the establishment of radio resource management connection to the radio resource management sublayers. After RR connection is established, the network may start the mobility management procedure for authentication, and it is going to check the temporary mobile subscriber identification, reallocation, and the network may also be asked the resource management to perform the ciphering mode of setting, because the authenticated user only should receive and the authenticated user only should send the message to the particular receiver. So, after the successful completion of these mobility management and the resource management procedures, so the connection is established and finished, and the control management or the connection management entity that requests the connection is informed that is going to exist. So, next come to the resource management, that is the radio resource management. So, under this still we are dealing with the layer 3. So, under these radio resource sublayers, so the RR sublayer communicates directly with the layer 1 for the exchange of information related to the measurement, control and channel management. The primary function of RR procedures is to establish, maintain, and when no longer is needed, release the dedicated connection between the MS and a BTS. To achieve this, the RR procedures include the cell selection at power on, handover and cell reselection during the idle mode. So, to recovery from the lack of services during the idle mode, so the cell selection procedures are performed in conjunction with the layer 1. So, in fulfillment of GSM phase 2 recommendations for PLMN selection, so the MSRR functions include the procedure for the reception of BCCH, that is nothing but the broad channel control, and the other one is the common control channels. So, when this idle mode. So, the network radio resource management functions that also include the broadcast of system information and the continuous transmission of the paging information. So, on all page sub channels to the MS to the ideal mode. To establishment of RR connection, that is a radio resource connection, may be initiated by the initiator should be there to utilize all this management. So, or to handle by all this management, that is the mobile station or the network. So, on the mobile station, the movement management, mobility management sublayer requests the establishment of radio resource connection, or on the other network side of radio resource entity that transmit the paging message. In either case, that is MS and the RR entity transmit the channel request message that asks for the signal channel. So, the network respond by allocating the dedicated channel to the MS by sending an immediate assignment message. So, next is the message format. You are able to see it on the screen, that is the message format for layer 3. Before that, when the connection is going to establish, that is while RR is connected mode, so many operation can take place, and some of these operations are going to be entities for upper layers can send messages and their peer entities. So, RR sublayers on the network side send the information on the downlink radio channel, and the RR sublayers in the mobile station sends the RSS message reports to the uplink radio channels. So, these are the operations parallelly going to be handled while it is going to be under radio resource management. So, that is only one RR connection, that is a resource allocation connection can be established to one MS at a time. So, after releasing the RR connection, So, the normal release procedure may be initiated or the radio link timeout procedure may be activated. So, next you are able to see the message format for the layer 3. The format of a GSM layer 3 message as shown in the figure. So, it is going to have the protocol discriminator, that is identified by PD. The code that indicates the type of protocol message belongs to that is the connection controller, service, supplementary service, mobility management, radio resource or the short service messages or the call control. So, the next field of 4 bits is a transaction identifier TI, and within the CM layer, so that is the connection sublayers, in both mobility management and the radio resource connection messages. So, the field is set to all zeros. So, the next byte of the message indicates that the function of the message within the specified protocol or for a direction as shown in the figure you are able to see. Okay. In the resource and the mobility connection sublayers, the functions are related to the transport messages are defined, and the task of RR and MM sublayer is to examine the message header to determine the correct routing of the message either to or from the correct protocol entity by virtue of the PD and TI codes. So, this is about the layer 3. Next we move on to the layer 2, where it is going to have the location, LAPD operations, service access points, data link procedures, physical service required by the data link layer, data link timers. So, this is the diagram depicting that is the GSM protocol entities for layer 2. So, as already you know that is a LAPDM algorithm. So, it is going to used over the unified interface, that is a modified version of LAPD, that is in ISDN protocol. So, the LAPD is used in on the GSM, that is another interface is known as the GSM ABIS, that is the binary bidirectional interface between the BSC and the BTS. So, LAPD message can give have up to maximum 260 bytes per frame. So, the LAPD message consisting of a header and a layer 3 messages. So, for a transparent message from the network to the MS, the BTS removes the header information and remaining bytes of data are sent to the mobile station. So, however, the message is often too long for a single frame on the interface. So, the LAPDM segments on the message into a number of smaller messages, and these messages are sent over either the 4 burst or the 8 half burst after undergoing convolution coding. So, what is LAPDM operations? So, LAPDM operation supports 2 types, one is acknowledge, the other one is unacknowledged. So, the message do not need the acknowledgers are sent by the unnumbered information, that is UAI frames. So, this implies there is no error recovery or flow control operation in the place of information transmission. Acknowledge operations occurs when the information is sent within the multiple frames, and the layer 3 messages are sent in the numbered, that is the numbered one. So, each numbered one. So, each one frame must be acknowledged before the next frame may be sent. So, the multiple frames mode is initiated with the set of asynchronous balanced mode, that is known as LABM. So, LABM added advantage, that is adds overhead information depending upon the type of the frame to be sent, whether it is acknowledged or unacknowledged. So, the different control channel use different frame formats. Some of the types of information contained within the frame field like adders, information format type and the length indicator. So, the details of various frames field will be discussed in the later of this module. So, the service access point, that is SAP here in this case. So, between the layer 3 and the layer 2 has a specific value, each of the function that is on the channel, it is defined as the DM. So, next we move on to the data link procedures. So, under this data link procedure, that is figure shows the as shown in the figure you are able to see, that is 5.51 in this figure. So, that is the data link layer, that is data link connection for SD standalone common control channel and the slow access common control channel. So, that is which is going to terminate at service supplementary service that is access point, that is SJBIT is equal to 3. Okay. So, the data link procedure is performed once and each type of physical channel is supported by the SAPI. So, the procedure examines, that is a frame control field and the length indicator field. The procedure performs a segmentation and reassemble for the layer 3 message. So, the data link distribution procedure is invoked whenever there is a more than one SAPI or on a physical channel. The procedure is going to examine the address field of the frame and the type of the physical channel to determine the correct data link block to deliver the information to. So, the next is going to be a physical layer, that is the layer 1, physical layer operations. So, the physical layer or the signaling layer 1 as the actual physical hardware modulation scheme, that is the channel coding and used to send the bits over the physical channels on the interface, air interface. So, the physical interface through the various control channel. Additionally, the physical layer interfaces with the other physical units such as the speech coders and the terminal adapters to support the traffic channel, traffic channel and all. So, this is about the interfacing of the GSM network architecture. Hope you got benefited from this video. So, we shall see in the next video related to the other modules. Thank you.